All right, so what I'm going to do now, I'm going to show you a new app called the Tvm Solver. I mean, you could see that we could solve a problem like this using the formula, the formula from before here. There's actually something else you can use called a Tvm Solver. If you read in the textbook, they actually show you the Tvm Solver. I don't think it's in Desmos, but it does come with a TI-83 graphing calculator. But again, I'm not requiring you to have a graphing calculator. I mean, if you have one already, that's great. But we don't need that because there's a website here. I'm not sure who made this app. It wasn't me though. But someone made an app in GeoGebra, which is the Tvm Solver. I mean, here's the link. There's a link I posted on Blackboard as well. So basically here, you'll see what I mean when I open the app up. There's a capital N, and that's the total number of payment / compounding periods. In other words, it's little n times t, how many compounding periods there are altogether, which is the same as how many payment periods there are. In the app, I'll present it in a minute, capital I, that's the APR, but you leave it as a percent. You don't convert it to a decimal. PV is the present value. It's basically the amount in the beginning. It's the beginning amount. PMT is the same as before. It's the monthly deposits for us. But again, they must be regular payments, which is what we're using, assuming that is. FV is future value. That's how much we're going to have at the end, in the future, that is. It's the end amount, that is. That's better. It's the end amount. The accumulated value. How much will be in the account after all this, after the situation, that is. These here, this is how many payments there are per year, monthly payments. This is how many compounding periods there are in a year. And in this class, again, these two are always equal. All right. These two will always be equal. That's what I have here. Okay, before I go on with the slide, let me get to the solver to show you it. Okay, there it is. All right. Okay, let me just share it now. There, no, here it is, here it is. Okay, you should see it in a second. Here it is. Again, the website, it's on the slides. It's also posted on Blackboard. This is that Tvm Solver. This is our capital N, which again is little n times t from our formula. Again, that's n is how many compounding periods there are in a year. T is time in years. Capital I, that's the APR, the interest rate as a percent. The percent sign, the percent symbol here is there to remind you that we're not converting it to a decimal. We're leaving it as a percent. PV, present value, that's the initial balance. PMT is that monthly deposit. FV is how much we'll have at the end, the future value, that is, the end balance. P over Y, that's how many payment periods there are per year. How many payments we're making in a year. C dash Y is how many compounding periods there are in a year. That's how many compounding periods there are per year. These two, again, are always equal to each other. P slash Y and C slash Y. You'll see also, the book mentions this as well. If any value is missing, but you have values for all the other entries, you could actually solve for the missing value. So if you know everything except how much we had in the beginning, you could solve for that. You just click solve for PV. And that is useful. You might wonder, well, what would we have to put into the account now to have a certain amount later on? So that would be useful. Or what would our monthly deposit have to be? Well, if you put in all the other data values, you could solve for PMT. You could do that. All right, so that's what that TVM solver looks like. Now, before we do some examples, there's some other stuff I have to point out with it. Let me just get back to the notes. Here it comes. Here it is. Just to let you know, if you look at the bottom, sometimes that TVM solver could give you negative numbers, and that doesn't mean something is wrong. You could get negative numbers here, but again, that doesn't mean something is wrong. What happens is that money that goes away from you, like money you pay, or money you deposit, that is, for instance, those are negative numbers. Inflows, like money you're taking out of the account that's coming into you, that's what they call a cash in. They can call that a cash inflow. Those are actually positive. So money that's coming directly to you, that's an inflow. That's positive. Anything that's leaving you, even if you're putting it into an account, your account that is, it's still considered a negative number, such as deposits and loan payments. Well, loan payments also, they're considered negative. We'll get to that when we do loans. Okay. All right, come on, let's keep going. All right, here we go. So here's an example. This is actually the one from before. We're going to solve it using the TVM solver. So again, let's suppose Mary is depositing $100 each month into an IRA account, and the account is earning 9% interest. We want to know how much she's going to have in 20 years. Okay, and again, we did not state explicitly the compounding frequency. We're assuming that the account is being compounded as often as she's making, as often as she's making deposits. So compounding frequency, she's compounding, the account is being compounded monthly because she's making monthly deposits. Okay, so to use our TVM solver, right, we have to put in this data. We have to know what these data values are. Well, PMT, that's her monthly deposit. That's a negative number here for the TVM solver. Negative $100. Okay. Capital I, excuse me, I was yawning. Capital I is 9%. So it's just 9 actually. You don't convert it to a decimal here. Now, capital N is little n times t, right? This is going on for 20 years, so t is 20. And that's how often it's compounded, right? In a year, how many times? That's 12. 12 times 20 is 240. We want to know how much she'll have 20 years later, how much she'll have in the future, right? The end result. So that's our unknown. There's nothing in the account to begin with. So PV is 0. There's no initial balance, in other words. And we said already that it's being compounded 12 times a year. These two are always the same, so they're both equal to 12. So we're going to put this into the TVM solver. So I have to stop sharing and bounce back to TVM solver. I know it's annoying because I'm not sure. I don't think there's a way to share two things at once. So, but what are you going to do? Here, let me put it in. Okay. All right. Okay, so here, what are we going to have? So we have our capital N, right? That's 240. Okay, they see what I'm doing? Yes, they can. Good. Capital I we said is 9, right? PV is 0. There's nothing in there initially. PMT, right? Negative 100. FV is what we're looking for. So we can leave, I mean, we can leave it blank. We could leave it at 0. It doesn't matter because we're going to click on this. There are 12 compounding periods. These two are always equal, so we'll make them both, not 112, excuse me, 12. Now we click solve for FV, and we actually get the same amount, I think it's the same amount, that we got from the formula. Let me take a look. Pretty sure that's what we got from the formula, though. And yes, it is. You get $66,788.69. All right. If I forgot to make this negative, what would happen is this. This would end up becoming negative. No, it's just something to consider. I mean, generally the negatives aren't going to be too big a deal. So, all right. Are there any questions about this? Okay. So let's get back to the notes.